Karan Parekh. I'll be your instructor for today. I know Rajdeep has been taking most of your sessions, and he said, many wonderful things about this batch, with Streamline and All Pixels. I hope all of you have been enjoying the training session so far. I'm one of the co-founders here at Green Rain Studios, and my area of expertise in Unreal is largely in immersive experiences and virtual production. I've been using the engine for a number of different things, but I think the some of the areas I'm strongest in are blueprint, visual scripting, and a lot of different hardware integration. I've done a bunch of different virtual production projects, animation projects, and simulation projects with Unreal, and I'm excited to share some of what I've learned with you. The format for today's session is pretty different from most of the topics we've gone through so far. Uh, Today's session is a little bit more of an overview into the process rather than being a fully hands-on session in the way Rajdeep does. And we'll also be talking about a little assignment that all of you will be working on over the next uh, month or so. It's largely just a way to tie in everything you've learned so far, in the sessions that have been conducted by us, and should be a lot of fun. It's not very different from what you've done in the past, but it's just a chance to tie it all together. So you are going to create your first, cinematic or game cutscene or whatever you want to call it, but you will create it entirely in Unreal and render it out of the engine. And we'll have a few more topics after today as well, but I think we've covered almost everything you need to pull off this assignment, especially when we consider some parts of today's session. I think you'll be in a good place to start with the cinematic assignment. So let's start there, and then maybe we'll even end a little early because I know it's hard for you to find time during the week, so maybe you can utilize some time today during the session to start your assignment and even discuss some of this. So let me just share this with you first. So hopefully all of you can see my screen now with the assignment on it. Sachin, is the assignment visible? Okay, perfect. Yeah. So, you know, it's it's very open-ended. There's just a theme, but really creatively, you're free to interpret it how you choose to. So the reason is just that there's a coherent theme, but it's not to really stifle creativity, and it's just to give a little bit of direction. So you will be creating a short cinematic sequence rendered out of Unreal. The theme we'll be sticking with is freedom, and you're free to interpret that in any way you want. um there are certain things we want to make sure you're able to do as a result of finishing this assignment. So you should be able to import some models from outside the engine and bring them inside. So we're talking about 3D models. This could be from the marketplace, this could be something someone has custom created in another DCC. It could be things from Quixel Bridge. We've done the asset import session, so you know your way around bringing models into the engine, but you will make sure that you have you're bringing in some models. Then the next thing is deploying effective lighting and material systems. Now you can create a stylized or photoreal look. It doesn't really matter. You can go stylized or photoreal. So I'll just make that modification here. So if you want to go for photoreal, that's up to you. And yeah, the character pipeline, again, that's part of the asset import. We will be doing perhaps a little session on MetaHuman, the MetaHuman workflow in Unreal, where you can leverage Epic's new pipeline for digital humans that you can fully animate within the engine itself. Some really neat features, and extremely photoreal characters as well. But you're free to use, so I'll point you towards some assets that I like to use that could accelerate your workflow. And lastly, you'll be using cine cameras and sequencer. So just it kind of goes back to the session we did on sequencer, and you will use that to render and create this short sequence. There are just some minimum requirements. So we want this cinematic to be at least 30 seconds long. There's no upper limit, but once you start get, once you get past 2 or 3 minutes, it gets a little hard to finish in this timeline. So depending on your bandwidth, I would say ideally somewhere between 30 seconds to 90 seconds is a good place. But if you're largely using the same environment and you have maybe dialogue happening between characters, that's kind of easy to do. The other minimum requirements are, you have at least one character, and you have you could have two separate environments, one indoor and outdoor, just because each one requires a very different approach, to lighting and scene creation. But you're totally free to use any third-party content, anything that may come from the marketplace, Quixel Bridge. So it's really not an asset creation assignment. It's more to put things together. So feel free to use any ready assets, any ready models, ready animations. And I'll spend some time right now just pointing you through, walking you through some resources that are easily available. A lot of these are free. You don't need to necessarily shell out any money. You'll find a ton of great free assets, and I'll just point you towards some of these right now. Some obviously are within, you're already aware of the marketplace, but I'll just walk through it once and talk about some of the assets that I think will be really good for you to use if you're a little confused and don't know which assets you want to start with. So I will stop sharing this. But any questions about this so far? Do you feel like you're in a good place to attempt something like this? I've been seeing some of the work you've been sharing on LinkedIn, and it looks great. Thank you for tagging us in that. It allows us to see what you've been up to. So thanks for that. But yeah, in fact, some of what has been shared on LinkedIn is very close to what we're expecting you to do anyway. So if it seems like some of you are already in a very good place to try this. And like I said, you've got about a month to finish this, so you'll be submitting this on the 12th of November. And yeah, we'll be able to support you during the process. If you're running into any issues, bugs, anything of that sort, we can start setting aside some time during the sessions, during the training sessions, maybe the first 30 minutes or the last 30 minutes, to kind of go through anything that is not quite working in the way you expect. We're happy to dive in and debug. So yeah, just any questions about this? Any comments? Stop presenting this.
No, everything seems clear.
Okay, great. Thanks. All right, so I'll share my screen with you. And I'll urge you to check out the MetaHumans on your own when you have some time. But this is it. It's totally free to use right now. You can actually create your own custom characters as well, but you do need to sign up for that. But if you just want to use some of the default characters that are ready, and all your animations and all of that will transfer over. If you end up changing the character, uh, that will still work for you. I'm going to drop the link in the chat because there is a little bit of loss and lag, so if you want to actually check out some of these videos, I will be playing them here. But for your characters in this animated sequence, I think the metahumans are absolutely great. I'm sure most of you have probably already seen this, but this is fully rendered in Unreal in real time. And if you want a photoreal look, I think this is you'll be hard pressed to find better assets that you can create this quickly. So it comes, with cloth simulation, hair simulation, all of that is already built in. And this is, a result of the years of work that have been put in by Epic, Three Lateral and Cubic Motion. So Epic ended up acquiring those two companies, and a lot of their pipeline has been integrated into creating this awesome digital character pipeline. The other really cool thing is you can animate this directly in the engine as well, right? So if you want to, animate it outside, you can, but you can also animate it directly within the engine. There aren't too many ready animations available for the MetaHuman, so you will have to go through a process called retargeting. We may actually cover that in a future session, if it seems like something that is important to you. But for any of you that have iPhones, you can actually use your iPhone to drive the character's facial animations, right? So it's a form of performance capture where your iPhone has a sensor that will track your facial movements and map it on to the MetaHuman. So that is really really awesome and really powerful, and it will save you a ton of time animating. So you can definitely check this out. There's another really good course that just launched on the Learn tab. It is so to supplement your learning with us, I want to point you to the learn.unrealengine.com tab. We have some great self-paced tutorials. We're mostly doing our sessions, once every 2 weeks. So if you do want to accelerate your learning path a little bit, I'd heavily recommend doing some of the courses here. They just released some courses earlier this week, um, and so I'm just setting a filter here. So this is learn.on, and there's this one, animation for virtual production. This is a really good course to go through. This is brand new. I've done a lot of these courses myself, and even though you may have used the engine before, I think the way some of this is explained, it helps bring a lot of clarity. So this talks about a tool called Control Rig in Unreal, where you can animate directly in the engine. So this is a good one to check out. If you are feeling pretty lost in how you could put together this cinematic, do check out this one over here, Independent Filmmaking with Unreal. It's a really nice course, and it's quite comprehensive, and you will kind of build a full cinematic, end to end anyway. So you get some of the assets. So if you're having a hard time, kind of on the creative side, you can just pick this and kind of execute this and build this with some tweaks of your own. And a lot of other things that you may want to dive into that we may not be able to cover during our courses. We do have a number of sessions coming up, but there's only so much we can cover in live sessions. But there are, I believe, over 70 courses now at this point. So if you want to accelerate, this is a great place. If you want to dive deeper into materials, lighting, audio, areas like that, blueprint, this is a really solid place to get started. And you can always reach out to us if there's something that's confusing or tricky, anything you need help with, we're happy to cover. They have some good sessions on VR. They've partnered with Oculus for the VR courses. They've partnered with Microsoft for mixed reality courses using the HoloLens. So it's, yeah, this is a pretty good resource, and I recommend you check it out. So these are some of the courses I was talking about: Oculus VR production for Unreal, HoloLens 2 mixed reality production for Unreal. And also, if you just want to dive much deeper into the rendering pipeline of Unreal, how an image is put together, uh, the rendering courses are actually very comprehensive. And today we are going to be covering rendering, but from a very different perspective. We're not really going to be talking about how an image is put together in Unreal. That's largely theoretical and for you to understand. But today we're just going to be talking about you know how do you get images rendered out of the engine for a cinematic, not necessarily real time rendering in the viewport, how that image is put together. So yeah, do check this out. If you have any questions or concerns about the assignment, let us know. But again, it's really a function of everything we've covered so far. All in all, you could put this assignment together maybe in, like, I'd say 8 to 10 hours is a good target to set for something simple that matches all the minimum requirements. So if if you feel like you don't have the time to do that over the next month, if you can't set aside 8 to 10 hours, just let us know. uh, we can discuss with your management and find a way to perhaps extend the timeline or something like that, but it should be enough. Like I said, I've already seen some of the work you've been uploading on LinkedIn, so it's very much in line with what we're expecting you to do anyway. All right, so let's talk about, let's get into the engine. You can open any project that you created in the past. You know, if you don't, you can just go with good old starter content and open one of the test maps. We're going to be talking about post processing and rendering today. It's going to be a pretty short session, uh, mostly just to give you some time back, so you can get started on the assignment, start thinking about, what you want to create. So I'll share my screen with you. I have a sample project open. I'll show you which one it is. If you want to download it at some point, you don't need it. Everything I'm doing, you could do in any other project as well. So I'm gonna share my screen with you again. And this is the Unreal Blueprint sample project. So you will find this in the Learn tab of the Epic Games launcher. And now that we're here in the launcher, I do want to point you to some of the other resources that will be extremely helpful as you do this. So we're in the Learn tab right now. And if you scroll down, you'll see the Blueprint sample project over here. This one. This is the exact same one I'm using right now. But just talking about, the cinematics. So I'll point you to some projects that are fully ready and built and, built. So the Slay animation sample is brand new. um it is like a perfect example of what you could build with the engine. So this is really really neat. um and you can download this just to check out the project, understand how it's put together. There's a lot of good action sequences in this as well. So there's this one. Then there is the Meerkat demo. Now this one's really cool. This is actually done in collaboration with Weta Digital. And Weta is one of the world's top VFX companies. They've been behind a lot of blockbuster Hollywood movies, Avatar being one of them, Lord of the Rings being the other, the whole trilogy. So they've got a strong track record for delivering some of the best visual effects we've seen. And they created this Meerkat demo to test out Unreal's hair and fur system. So Unreal has a pretty powerful real time hair and fur system where you can and feathers as well. So there's a bird and there's a meerkat in this one, and you can see the but they've also utilized a lot of other features in the engine. So really cool animations as well. You can see how an animal is set up in the engine as opposed to a human. And when I say character, your character could be an animal, it could be stylized, it doesn't need to be a human. um, so there's a meerkat project. And the great thing about these projects is you can download them and kind of reverse engineer them and see how things were put together. Now these are quite complex, some of these projects. With a lot of the basic training we've done, there may be some parts that are not very clear, but nonetheless, just looking at how the sequence is set up, how the asset is set up, you can actually use these same assets in your cinematic assignment as well. So if you want to use this meerkat, or if you want to use Echo from this project, she's the protagonist here, feel free to do so. You're welcome to use all of these assets. Then there's a metahuman sample project where it comes ready with two metahumans already, and they're completely animated in the engine. You can see how they've been keyframed in sequencer and animated. So this is another good asset to check out. Um, I really like this Archviz interior because it's a very refined interior environment. There are no characters or anything, but if you want to look at an environment that is extremely well lit and photoreal, this is a good one to check out. And Subway sequencer. This is a little old at this point, but really nicely done. Some very moody kind of lighting in the subway, and it starts off with a hardcore fight scene where and it has a nice plot twist at the end. I won't tell you what it is, but check it out. It's a short sequence. So these are some projects that you can just download, start exploring, get a deeper insight into the workflow. Because so far, what all these sessions that we've done, we cover a certain part of the engine, but we've not really talked about the bigger picture and how all of this necessarily comes together. And I think downloading some of these projects will give you a very strong start, and just to understand what the level of complexity is in something that's refined. Now most of these projects have about teams of close to 10 people working on them. You are kind of doing this, each individual will be submitting an assignment, so we don't expect it to be anywhere near this level of complexity. But if you've been kind of tracking what's happening with Unreal on LinkedIn, or just generally, you may have heard of their fellowship program that they have. It's another intensive training program that Epic offers, and it's it's about a month and a half long with training every day, and at the end of it they're asked to create a similar animation sequence, and a lot of that has been uploaded to Vimeo. I think every single entry has been uploaded. I'll share that with you. It will just give you an idea of what somebody who's gone through a month of training is able to do. So there's a playlist, and this is the program as well, and you can check out the playlist as well. And right now, the fellowship program is largely open to folks from the visual effects industry, but they will be having something similar for games as well at some point. So this is on Vimeo. I'll just share the sizzle reel with you. I think they have a nice sizzle reel here. So drop the link to that. So that's the link for the some of the videos from the fellowship. I'll just play it to show you. This is really neat because this is mostly people who have not used the engine before in any capacity, and they start out using it for a month, but it's every single day. So they go through about 5 hours, 3 hours of training, and then 2 hours of lab time every day. So it's very intensive, and they're obviously able to cover a lot of different topics because they're doing this 5 days a week for at least 5 weeks, so a little over a month. And a lot of them do end up using ready assets, right? So Echo, most of them are using Echo, the same character from the example I showed you. So obviously this is the best of the fellowship, the best. But if you go through the whole playlist, you'll get a general sense of what the average level is. There have been about 600 or 700 people that have graduated so far from this program. So this is really highlighting, the top perhaps 5% of the work. And just last thing I want to show you is in Bridge, in Quixel Bridge, where you can find. So you'll actually see over here, all your 3D assets are here. You've probably gone through this during the asset import session, but all of these assets are, fully optimized for the engine. You can bring them right in if you've got the plugin. So you just need to make sure you have the plugin and the setup done correctly. But all these assets are at your disposal. I think we've already covered, the 3D assets. But if you go here, there's the MetaHumans tab, and there are 58 of these MetaHumans that you can just that they're completely ready to be plugged into your project. So you can use any of these. Again, if you want to customize, there is the MetaHuman Creator. It's a cloud software that Epic offers. You can sign up for that. It is not fully production ready yet, but it's worth trying out, especially if you want to, create a character that has likeness to yourself or someone and you want this, the assignment to be more personal. A lot of people have tried that and created their own metahumans. And again, this is like any other asset in Bridge. It's a one-click export. Once you kind of sign in, download the asset, and then you can just export it once it's downloaded. So in the MetaHuman sample project, you'll find Taro over here, and yeah, Taro and Ada. They're the two that are in the sample project. So if you download the sample project, you don't even need to go into Bridge. Like if you want to use one of these two. Then you've obviously got your marketplace assets here. So we talked about the Learn tab where you can find some stuff. We talked about Bridge, marketplace. Again, you can filter, by environments, by characters, whatever you want to, get. There's a lot of, so if you go to the free content, there's a ton of great stuff, especially under Epic Games content. You'll see that, uh, with some of the characters from a game called Paragon, right? They've got some really, really good animations already, a lot of good action animations because this is, a game that involves combat. And I think there are over 20 characters from Paragon and very different, some beasts, some pixies, it's stylized, it's different. So these are really good assets, set up for a AAA console game. For you, it may be very relevant because you can look at the way they are optimized. Now, bear in mind this game is fairly old at this point, and the engine has come a long way. So take what you see with a grain of salt because you like if you just compare this to the metahumans, how much further kind of shading and rendering has been pushed in the engine. But nonetheless, these are still really good looking assets. They will in fact, people have used them in the fellowship, and I've seen other people just upload these really cool fight sequences they've created with Paragon characters. So feel free to check these out. There are also some good environments that you'll find here. So that's great. Now, when it comes to animations and characters, I do like Mixamo quite a bit. So let me just share that with you if you've not seen it before. Um, it's free to use, and a lot of these animations are created. And again, you can just sign up for free. It needs an Adobe account that you can link with your Google ID. Now, all of this just works pretty seamlessly with the engine. So you can see you can pick from some of these characters, you can't really customize the characters here on Mixamo, but you can, once you have the file, you can definitely tweak it in any way you think you want to. So I'll just go through this process real quick, just to show you how easy it is to get one of these animations in. I'm just gonna take this alien soldier and use this character. So you can select a character, and you can select, any animation you want. Let's go with this silly dancing animation. So you can preview it over here. Now, just a quick tip, right? When you are working on a cinematic, I recommend you do it at 24 frames per second. It adds a nice cinematic flair to it. Games were typically doing 30 to 60 frames per second. I'll be talking about this as well. But make sure your animations are also downloaded at 24. So you'll have an option to do that over here when you hit download. And frames per second, you can set it to 24. But at least your final cinematic output render, you want that to be at 24 frames per second. This should be a pretty quick download, and you can see there are some parameters you can tweak here, like if you want to bump up the energy level. These are all very specific to the animation. So for each animation, you'll see different sliders over here to tweak the effect of the animation. And you can just drag and drop this FBX into the engine. Just gonna create a folder here. And you just want to make sure you have this import animations box checked. Once you have that checked, you just hit import all. Unreal will mostly take care of everything else. And then this is, pretty much ready to use with sequencer. You'll find all sorts of animations here, a lot of general kind of walk, sit cycles, and uh, idle cycles. And then you'll find some action, you'll find some dance sequences, you'll find a bunch of different things. Yep. So like you can see this, it just works in the engine. Very quick. Took me just a couple of minutes to get this in. So Nixon was also, really easy. And there is a process in which you can map these animations to your MetaHuman or, some other character. Cool. So I think that mostly covers the assignment and, where you can find some assets. Any questions on any of that? Okay, I'll take that as a no. So just let me know if anything comes up. Feel free to email us. Happy to help. All right. So let's talk about rendering, right? And what the process is in Unreal. What are some of the things we need to just be aware of and think about? So I mean, the simple way, and I'm sure all of you are already aware of this, uh, but rendering effectively in this case is, the creation of a frame or an image that you're going to see on screen. And, the fundamental components of that are pixels. And in Unreal, right, it's so everything we're seeing in the viewport is being rendered in real time. And real time is not the case for all types of rendering, right? So if you look at like a Pixar movie or a DreamWorks movie or something like that, they may take days to render a single frame in that film. But when we talk about a real-time rendering process, like we're seeing in this viewport right now, this is typically, when we talk about real-time rendering, it's happening typically at least at, you're seeing the image uploaded and updated 30 times a second. That's 30 frames a second. And it's happening so fast that it seems like it's happening in real time. So that's where the word comes from. But it's not a new concept. It's been around for decades. you know eh, the very first video game, right, was, using real time rendering. So it's not a new thing, but it's advanced significantly over the years. The level of realism that we're able to push, obviously, as you've seen some of these demos with Unreal, um, it is everything you're seeing that it's being calculated. And there's been a lot of, technology breakthroughs that have brought us to where we are. And I think we're at at the dawn of a new revolution in the role real-time engines will play. uh, I'm guessing you've heard of the metaverse at this point. It's a buzzword, but I think beyond the hype, there is a very, very strong business use case. Just in terms of potential, in the way that it'll change the way we interact, transact, uh, and just live our lives. I think, a lot of that moving forward is going to be, leveraging the technology that is in the metaverse. So the roots are very much in gaming right now, but like you've already seen, the engine is being used for many, many things outside gaming. We've here at Green Rain, we've done a number of, very serious simulation projects using Unreal. We've used it for architectural visualization, for film and animation pipeline. So games has been the standard for a number of decades. But real-time rendering engines are being used for all sorts of things right now. And you can see something like Fortnite slowly becoming this, social metaverse, so to speak. But there are a lot of other use cases like that. Like if you look at Roblox right now, that's another sort of metaverse that's built on top of Unreal. And ultimately, the metaverse will leverage many, many other things like extended reality. So your VR, AR workflows will find their way into this. AI and machine learning workflows will find their way into this. And eventually, we will be, it's like the next version of the internet, right? Right now we're looking at flat screens, but once you get into a world that's 3D and dimensional, and everything has spatial context as well, uh, you'll, I think we'll be seamlessly moving between these virtual environments and physical environments at some point. So again, the building blocks of the metaverse, entail real-time rendering. Of course, everything needs to be rendered on the fly, and that's what we're seeing happen in our viewport right now. So as we move our camera around, we're constantly seeing the scene update, near instantaneously. So the first thing we want to be able to do is just get a sense of how many frames a second we're seeing, right? So if you have a project open, if you don't, good point to open up some project, but I'll just show you. You will find the first option here, right on the top left corner of the viewport. It says show FPS. Now this is actually really good. You want to have this on when you're developing, and I am very close to 120 frames per second. Now, most games, right, as a minimum requirement, you expect them to run at 30 frames per second. Anything below that starts to feel like it's lagging a little bit, that it's not smooth enough. Uh, you just in terms of response time, right? It leads to some dissonance. So at minimum 30 frames per second is the target, right? For any game, for any interactive workflows, that's the minimum benchmark you want to hit. But 60 is preferred, and anything higher than that. But so 60 is also very, very standard, and what a lot of people are pushing for. But there are certain types of experiences where you want to be, in fact, even higher than 60. So when we're talking about VR experiences, you want to be at like 90 or 120, because frame rates below that, especially below 60, when you're in virtual reality, it really starts to kind of break the illusion, and it leads to a lot of discomfort as well. So while we talk about rendering, right, there's another concept that we need to keep in mind, which is optimization, right? It's because, again, your computer is only able to handle a certain amount of processing, right? To put all these pixels and create this frame, it's got to do a bunch of different things, and the more it needs to calculate, the harder it is for it to kind of hit the benchmark that it needs to hit in terms of frames per second. So when you approach Unreal, when you approach real time rendering, or if you're doing this with any other game engine, from the get go, you're thinking about how you can optimize and streamline things, right? Like I said, there are different workflows that a company like Pixar or DreamWorks would follow. They are maximizing their output for visual fidelity over everything else. They don't care if it takes them a day or two to render a single frame. But with the constraints we've got, like let's say you want to render at 60 frames per second, if you do the math, that means you have only about 16.67 milliseconds to render a frame. So in most offline rendering, so when I say offline rendering, I'm talking about the kind of workflows you'd find in traditional architectural visualization, in traditional animation projects. Frames could take a couple of minutes to render at minimum. That's very, very standard. They're able to do a lot more calculations, and they don't need to cut corners and almost cheat in the way that you would with real-time rendering. So real-time rendering also requires you to you know sometimes create illusions, something that might look like something. So we very carefully and smartly, for objects that are very far in the distance, we may just use planes as opposed to 3D models. All of this, so just bear in mind that there are only so many 3D models you can handle. There are only so many shaders that you can handle, materials. We've, Rajdeep talked about materials. There are only so many lights that you can put in real time, and there are only so many shadows that can be calculated. So this whole process, right, this whole cycle, and that's just on, I was just talking about the asset front, but on the code front, if you're writing a game, there are only so many things you can calculate within a second. So if you want to hit, that benchmark, right, that 60 fps, 90 fps, depending on whatever your target is, you need to very actively start thinking about what you're putting into the environment and be smart about how you can streamline things. So just to talk a little bit about Unreal's rendering process, we're not going to dive too deep, but like I said, if you want to really dive deep into this, you can check out the real-time renderings fundamentals course on the Learn tab. It goes really deep into how a single frame is generated. But at a high level, I want you to know that by default, Unreal uses something called a deferred rendering pipeline. And what exactly is a deferred rendering pipeline? It means that there are a number of different passes, right, or calculations that take place first, a number of different frames that are calculated first, and these frames are composited. And composited is, if you're not really familiar with the term, you can think of it like, kind of overlaying or adding one image on top of another of the other, to get the intended look that you need, right? And a lot of these calculations are taking place in parallel, and then eventually being combined together to give you the final frame. So if you look at your viewport, you actually have visibility into some of these frames that are being rendered. So Unreal takes all these separate frames and puts them into something we call a G buffer. And the G buffer will, take these different frames, right? It will store them. And then these are composited in a very specific sequence. Um, and again, this environment is fully 3D, right? So we start with, kind of calculating. There's it starts with the geometry that's placed. Each asset, each 3D model we have has, a transform, and we've seen the transform over here, right? Each static mesh, every single mesh has a location, it has a rotation, it has a scale, and it's put somewhere in this environment. And the first step is all this geometry is kind of just built into the environment, right? And it's placed exactly where it needs to be. And once that's done, right, there are a number of other steps that happen, but ultimately what we're looking at is we're looking at a projection. We're looking at a 2D projection of these 3D assets that are placed. And through this projection, we get our perspective, right? So it's really from the perspective of the cameras we'll be placing. So right now, this viewport, we're looking at it through a camera, and based on the position of that camera, it's got to render a 2D projection of this 3D screen, and then it goes through a process called rasterization, where the environment has a lot more detail, but you only have so many pixels on screen, so it needs to carefully select which part of that asset to render. So that's a very, very high level explanation of what's going on. This is really deep and really complex, but just so you understand that there are many different frames that are rendered and then you know kind of put on top of each other. So you can actually see some of this here. If you look at your viewport, we've got a section here that says lit, and you can look at some of the other, the scene without any sort of lighting. This is obviously a lot more optimized because no shadows or anything of that sort are being calculated over here. But if you go to buffer visualization, you'll actually see all the different you know passes that are there. And this also ties very closely to the look dev session Rajdeep did, where he probably talked about different parts of the material, uh, like having a metallic channel, or talking about roughness or something of that sort. And this helps inform whether something is going to look shiny or reflective, or what have you, whether it's going to be opaque or not. And you can actually see all these different passes. So there's a base color pass, you've got the metallic pass, where anything that is a metal is going to show up as white, anything that's not is going to show up as black. So this helps you calculate a number of visual effects, like, okay, what is going to be reflective, what's not. So it's going to actually evaluate metalness, it's going to evaluate roughness in the environment as well, and then tell you whether something is supposed to be reflective looking or not. So once your lights are in, you know what's going to happen over there. So again, there is a sequence in which all these buffers are put together to give you your final image. So that's about what happens in the viewport, right? We'll kind of stop there. This is mostly just wanted to give you a high level explanation of this, and keep frame rate in mind, because that's very important. Once you start dropping below 30, that's a red flag, and you need to start optimizing. There are lots of different optimization techniques in the engine. But once that's done, right? Once you have, you know, your what we call our base pass, right? There's a whole another process you could run on this, and this is called post processing, right? So once Unreal kind of puts your image together, you can run it through a separate chain of events that we call post processing, and that allows you to add many additional effects to it. Now, a very simple way to think of post processing is, if you've used Instagram or Snapchat or Photoshop or anything of that sort, or Lightroom, uh, you're aware of the concept of filters, right? You can think of post processing a little bit like filtering. So if you have an image that you've already taken with your camera, and you're able to put some additional effects on top of it, that is post processing. And it is actually a very efficient way to do certain things if you do it in post processing. There are limitations as well, but we'll talk about those a little later. But post processing is very, very powerful, and a lot of the post processing features are actually on by default in Unreal. So there are certain settings that are just there from the get go, and I want to talk a little about those, just give you an insight into this. Some of this you can try out. I'll also point you to some, resources that are available over here. But like I said, Unreal has a lot of this just enabled by default. You've probably already even seen the post-process volume in previous sessions, but the idea for now is just to kind of go through it a little bit and also warn you about certain settings that are just on by default and you may want to switch off when you're building your environments, and then later you can always switch them back on. But strangely, some of these things are just activated by default in the engine. So let me get rid of this existing post process for a second, and you can see how our environment looks very different. If I hit Control Z and bring it back in, you see that the exposure has kind of changed. But if you want to find, so post processing effects and settings exist in a number of different places in the engine, right? They exist in your project settings. They exist in something called post process volumes that we'll be diving pretty deep into today. And then they also exist in your config files that are basically again tied to your project settings, but there are different places in which you can manipulate them. And also something called console variables where you can turn on and off certain effects, uh with, okay, which is one minute, let me take a look. Oh yeah, so Jonathan, if you realize your editor is capped at 60 FPS, there is a way to uncap this. If you actually go into project settings over here, right, and you type the words frame rate, so you can just go to all settings, and you go to frame rate. You can see here engine general settings, smooth frame rate, used fixed frame rate. So for certain types of games, you do in fact want to run at a fixed frame rate, right? But over here, you can set, the upper limit as well for what you want. And this is of course a function of, your hardware as well, what you can actually run. So you can actually set, the upper and lower limits for your game, especially once it's packaged and you're shipping it. But here you can actually set certain things, so you can go with fixed or you want to smooth. So yeah, you'll find these settings over here. So let's take a quick 5-minute break, right, and then we'll dive into post processing. Hmm, interesting. Okay. So that setting, right? Yeah. So Omid has, yeah, exactly. That's the one. Yeah. So there's CVAR. So obviously some of you already know your way around CVAR. So that's great. And yeah, the setting, Jonathan, in project settings is largely when you package your game or experience. So when it goes out as an executable, it will be capped. Yeah. Thanks for that, Omid. So yeah, let's take a short break. We'll be back in 5 minutes. Yeah, so let's get started with post processing. And I want to talk about post process volumes. So, if you don't have a post process volume in your scene, you can go here to the volume section and you'll. Oh, sorry. My bad. Yeah, so here we are, right? So, if you don't have a post process volume in your scene, you can go here to volumes and you'll see post process volume over here. You can always obviously use the search bar and you'll find type post and you'll find post process volumes. You can just drag and drop this into your scene. Now the way it works, right, whatever effects, whatever settings you have over here, um, it typically works. So I just hit the G button so we can see all the volumes, and you can see this cube that's created. And I'm just going to set a slightly different effect inside this, right? So a separate post-process effect. I'll show you what's going on a little later, but let me just set this up quickly just to show you, uh, the difference when we're inside this. So I have some preset, post-processing effects over here. And so see, this is when I'm outside this volume, right? This is my post-process volume, as you can see, the second one that I've put in over here. And when I enter this post-process volume, I've put a certain effect in there. And you can see as I enter, things look very different inside here. Goes back to the bit I was mentioning about filters, right? So you can see a bunch of these different effects. And I'll talk about this in just a bit, and how you might be able to create something like this. Again, it's a little, you know, I don't think we'll be able to cover too much of that today, but you can see immediately the look of the environment changes completely when I am inside and outside this. So let me get rid of this, and I've removed that effect. But once you look at the details section for post-processing, right, the first thing to understand is that by default, this is a volume. And once you're inside that volume, all your effects, all these different settings that I share will kick in, right? They become active. Now, there is a way for it to affect the entire environment as well. And that's what you will, in fact, find with most of the default post processing volumes that are in the scene. So I'm going to delete this second one that I have here, or maybe just hide it for now because we don't need it. Um, but you look at the settings here, right? There is something, if you type the words infinite extent, unbound, that means that whatever settings you have in this post process volume act across the entire scene or the entire environment that you have. So once this box is checked, right, whatever you have will kind of act all over the scene. Now, when you have multiple post-process volumes, it can get tricky, and there's a way to set priorities and all of that, but we're not going to do that today. So for now, you can just assume you've got one active. But this is one of the first things you may want to do when you actually, because I think once you're doing the cinematic assignment, or for most things, even a game, right, whatever you have, you will probably want to have one post processing volume that is unbound and acting across the entire scene. You will pretty much always want that, right? It will give you a lot of control over how your environment looks, what kind of you know uh, again, what is the intended look of your project. And post processing is a very, very important part of that cycle. So I think last time during the look dev session, Rajdeep must have talked a lot about lighting, shading, all of those aspects. But post processing is also a very, very important part to help you achieve the final look you want. So what you want to do is basically drag one of these post-process volumes in and then make it infinite extent. So the one that was there by default, this is the first one. You can see it's already checked. It is acting scene wide. But in the moment you turn it off, you can see it goes back to that overexposed kind of look. So one of the things you must have thought immediately is that post-processing can also control exposure, right? And a number of different things. So it's not just like over here, I showed you some very specific stylized effects, but beyond these stylized effects, it also controls some very, very important parts about the general image itself. Things like exposure, things like noise, things like a vignette or a bloom or something of that sort. It is actually controlling a lot of these different things. So first thing to do is put in a post process volume. Probably you want to make it infinite extent unbound, so it's acting at a scene wide level. Now, when we're working with a games workflow versus a cinematic workflow, where again the assignment here is to create a cutscene or a cinematic for, could be for a game, could be for a movie, whatever you have. But typically one of the things you want to do is lock the exposure when you're working on linear media, right? When you're going to be rendering out a video and you're trying to and this is very true even for games workflows, right? Before you actually, if you're a lighting artist, before you start lighting, you want to turn off, any automatic exposure changes, because it's actually changing the brightness of, the frame that's being rendered, and you don't have a good way to calibrate whether, your lights are even set up correctly or not. um, so what we do is we actually switch to something called manual exposure. So exposure is not changing. Now, for a game to have auto exposure on makes a lot of sense, right? Because you may be moving from, a nice open plane into a cave, and when you go into the cave, obviously it's much darker, and you, as a player, you want to be able to see the environment at some point. So Unreal has auto exposure enabled by default. That means that the brightness of the image will change when you go from, a lighter area to a darker area or something like that. That is an expected change that you will see in the viewport. So this interior is actually a lot darker than, the exterior environment we have here. And in general, for a game's workflow, you want auto exposure to be on. So gradually, it will kind of adjust. So it's almost like eye adaptation, right? Our eyes also adapt once we kind of move from, bright area to a dark area or vice versa. You will see a number of changes, like, the size of the pupils, the dilation of the pupils, all of that is kind of changing. uh, but again, when you are setting up an environment, you want to have a very stable exposure. So, like right now, when we go to our post process, right? Obviously, the first thing is transform. That's where your volume is located. You know what its scale is. Uh, that's kind of standard. But if you're going with unbound, transform is meaningless because it's going to act across the entire environment. And in this case, our transform is meaningless because our post process volume is actually unbound, right? So it is checked. So transform really doesn't hold much weight. The next thing, your lens, we're going to talk about that a little bit. That's kind of the, what's happening in the viewport. And I'll talk about some of these effects. It's much easier to see them in action. But before we cover bloom and mobile depth of field, we're not really going to cover. But exposure is probably the first thing you want to stabilize, right? This is how bright, things are going to be on screen. And you can see as I tweak this value for exposure compensation, you can see a change happening here. But the mode right now itself is set to auto exposure histogram. That means we're going to have a range. You'll have an upper and a lower range, and you can change the minimum and maximum brightness in this range, right? So it will go as low as this and as high as this, your brightness values. And then you can set some additional compensation on top. Again, this is auto exposure, works really well inside a game. Not really if you're trying to build the environment first. You can always turn it on later when you're actually lighting your environment. And then also for linear media workflows where you are trying to create a nice rendered cinematic from the engine, you want to stabilize. So the way you do that is you actually change the metering mode. This is grayed out. So you click this checkbox over here. And just bear in mind, if something is grayed out, so this is a little misleading about, the way Unreal's interface is set up. Sometimes you think when something is grayed out, it's not even active or that, but it's actually on and it's set to this default value. Right. So what you want to do is check this box and then you can override the default. So if we go to manual, everything is looking extremely dark right now, right? But we can adjust our exposure compensation, right? And now you'll notice when it's manual, it's going to be fixed. It's not going to fluctuate, right? So this is what you want to do. First is you'd want to find the right kind of value to stabilize this, and you can lock it. But if you go back to, auto exposure histogram, which is the default, you can also, another way to stabilize it is just to set the same values for min and max. So if I set both to 1 and, exposure compensation to 1, this is kind of base state, and this is not going to now vary because my minimum and maximum values are identical. I'm not doing any compensation either. So now it will not fluctuate at all. If I actually go into a dark room, it will not do any kind of eye adaptation. So this is where you can change it. Right, so this is one of the first things you want to lock. And if you are going back to varying ranges, right, like this, then you can also choose how fast it goes up and down, like how it transitions to a lower or higher brightness value. So that's speed up and speed down. Or you can have a custom graph that defines this. And yeah, obviously for linear workflows, you want to kind of make sure you're locking into manual, or if you're going with auto, you just set your min and max, and that's as good as it being locked. So that's probably one of the first things you'd want to do in your scene to stabilize it. So that is your auto exposure. Now talking about bloom next, this is something that is, so I'm just going to hit the G button. So, I go into game mode, but yeah, over here, just let's talk next about bloom. And this is also on by default. So if you look at this, the default value, 0.675. And Bloom has a very interesting way of exaggerating something that's already bright in the environment, right? It'll make it look more luminous, more emissive. So if you've got a light or something like that, this is with a high, and a really good way to understand what a certain effect is doing is to simply look at it at its lowest value and crank it up all the way. That will give you a sense of what it's really doing. Because if with really minor changes, it's hard to understand what's going off. So you can definitely change this, right? And you can see the effect here. But again, this totally looked like, so if I hit Control Z a bunch of times, it totally looks like this effect could not even be on. It's completely grayed out. But Unreal is deceptive in its interface in the sense that you may think that this is off, and only once you check this is this effect actually kicking in. So over here in this case, right, I have enabled it, but there is a slight, and a lot of this is actually stored in the engine default values itself. There are certain INI files that exist, and that's where all of this is set. But you can, override it in a way that makes sense to you. Again, just gonna set it back to the default over here, and this will take care of it now. Yeah, and now it's off completely, so you can just make it zero if you want it to be off. Initially, you want it to be zero, and then you want to tweak it to a value you want. There's also a threshold value, and the threshold decides when Bloom should kick in or not. So at what point does the effect execute? So higher the threshold, it will kind of not add the effect in most cases. And a lower threshold, you'll see the effect will kick in a lot stronger. And this is really a function of how bright something is. So again, if you want to set any of these to the default, it's just this little yellow button here, little hard to see, uh, which is why I'll use the magnifier over here. This yellow button, this may have been covered earlier, but it resets it to the default value. Right, so that's Bloom. But the method right now is standard, and that is good for games. It's very optimized. But if you have, again, if you're creating a cinematic, you can switch this to convolution, and that is a lot better looking, right? It will look a lot nicer, but it entails a lot more computation, and it could slow down your frame rate. So at the time of your render, you can always switch this to convolution, and it gives you a warning here. It says intended for cinematic, too expensive for games. If you're running really beefy hardware, you could probably run it with convolution bloom, but convolution bloom almost always will look better. So that's that. There are some advanced settings here where you can control the tints and all of that for your bloom effect. But I think that's probably enough about bloom at this point. So up next is, another one we should talk about, chromatic aberration. This is off by default, but it can, adding a little bit of this, can bring your image to life, make it look a little more like film sometimes. Um, and it will actually split your colors a little bit into RGB, because if you've got a lens, right, especially if you're trying to so I'll show you certain effects that use this a lot. But again, if you go all the way up, you'll see what's happening, and you'll see some color splits happening, right? Like if we go to a section here, you see the colors kind of splitting into, the separate red, blue, and green channels, with this intensity being higher. So really, really slight values actually help an image look more natural, like it was shot on a real camera or something like that. Because any lens, right, no matter how perfect, any real physical lens will entail a certain degree of chromatic aberration. A little bit will always happen. So really small values. And there's one more course I want to point you to right after this session, right? You can go through it. They talk about what, the recommended settings are for some of these values. So I'll share that with you. So that's chromatic aberration. It's a pretty simple effect. We'll talk about dirt masks in just a bit. When we start talking about post-processed materials, I'll talk about this. But this is very, very useful, very commonly used in games as well. So we'll talk about this. But it's basically, you can think of it like an image overlay that goes on top of your scene. So we'll go right back to that. Let's not talk about camera here too much. That's, we typically control a lot of this in the cine camera itself. So let's not discuss that here. We'll leave this aside. I don't think you should change any of the default values here for now either. Okay. Up next, you've got lens flares. Now, this is again, a very commonly observed effect with lenses. And I can turn it up, and you can see these little, as I move around, you'll see it. Especially this shows up over here when you've got bright things. You see this colorful. This is not an asset. There's no particle system or anything here. This is a lens flare post-processing effect that's kicking in, and we can turn it off with 0. Again, the default value is 1. That means you are seeing a little bit of it over here, and you can see it. And there are custom shapes you can send. So again, what we're seeing is the bokeh effect over here. This is, and it can make things look very cinematic if done correctly and in moderation. Some people definitely overdo lens flares, but a little bit can help you add a nice cinematic touch. And the bokeh shape, you can actually use a custom texture to define the shape over here. So right now you can see that a little circular, but also a little polygonal. So if you actually want to see some other presets that the engine has, and you can download a lot of these from elsewhere. So if you go here to view options in your content browser and show engine content, under engine content, um, bokeh, you can see there are a number of different options over here. So there's a circular one, and let me just switch this to bokeh 5 sides or something, and you'll probably be able to see that change. So you can see the size of, whatever's on the texture. You can see the texture kind of presenting itself here now, and you can make it big or small and kind of switch. Now we've got circular. This is, again, it's nothing but a texture. It's a texture with an alpha map. You can bring in your own textures. You find a lot of these online. Good, really nice bokeh shapes. So it will try and use this, and this is typically a function of the type of lens you're using as well. You can change the size. You can change the threshold. Is kind of when it kicks in. So this is, again, lower threshold. You see the effect more. Higher threshold, you see the effect less. It's got a much, tighter gate onto what it's allowing to pass through. So it's like kind of, intensity and threshold will actually control the amount of the effect you're seeing. And you'll notice there's like, most of these post process settings have intensity, and at the start you probably just want to make all of them zero, start with a blank slate. So, and yeah, that will give you a good point to just start working on your base environment, your base lighting, without worrying about post processing. And then you add your post processing, so then you'd kind of go and set your bloom values and all of that appropriately. But basically initially you may just want to turn all of this off, right? And yeah, you can obviously have tints over here, if you choose to. You'll see tint options for almost everything. We saw that for bloom, you have that for bouquet. This is where you can cause color variations to happen for that specific effect. Up next is vignette. Now again, this one is on by default, right? Very interesting. It will actually make your edges a little darker, right? And you can see this in action. So let's hit this checkbox over here. And once I reduce this value to zero, you can see it's a lot brighter on the edges. And once I turn this up, you can see my edges around the viewport get a lot darker. So this is 0.4, which is the default value that's there in the engine. So you may even want to turn this off because it could lead to some incorrect decision making when you're lighting your environment first. And because you may misjudge the brightness, so you want to turn this to zero. And a quick way to do that is, like, if you just in the search details, if you type intensity, just all the intensity values that are there under lens, just set them to zero. It's a very good way to start. And just make sure there's no funky post processing happening. And then once you're done with your lighting and all of that, then you can kind of come here and then start making the tweaks you want to make. So that's lens flares. That's And then depth of field, again, I would not recommend using the post process to do that. I would recommend using the cinematic camera to get a depth of field effect. Depth of field is basically, I'll show you how to enable this with the cine camera, but it's really powerful to create good looking cinematics. If you have a subject, you want that subject to be in focus, and you could blur out the background, and that's a really useful way to use these depth of field effects. So this is these are your lens settings. Now we've got color grading settings that exist over here. If any of you have used something like Resolve or After Effects or something, you may be very familiar with color grading. You have all the options to do that here. You can bump up specific highlights in the scene. You can play around with the shadows, all of that. So again, if you're going for a custom look, right, this is a great place to do that. Again, we don't want to dive too deep into this, but you'll notice that each one has kind of similar properties, and you can bump up specific parts of the spectrum, ranging from your highlights to shadows. So if you want to kind of accent the highlights more, you can definitely change it in a way that it is its intensity is more, and you can so again, this is your color grading. You've got settings here, and you can also just quickly, by changing the white balance, the overall temperature of your scene. You want a warmer look, cooler look, all of that you can see. And with tint, of course, you can kind of add a specific hue into the mix over here. And this is very commonly done in film, right? Like if you've seen the Matrix, uh there are certain sections where they use a tint when they're inside the matrix, inside the simulation, and then when they're outside there's a different tint. So there's like a very specific green tint they use, and it also helps kind of inform the mood. So color grading has a lot to do with mood, warmth, all of that. It's a powerful place. So I mostly just want to show you where the knobs are, uh, and then you can kind of play around, do your own research, and see what you want to tweak. But this is where your grading options exist. And then there's film. This is, again, you can play around with it and see how to change it. And you'll actually see for stylization, this could be very useful as to what kind of effect you choose to have. But just coming here next to rendering features, this is actually very, very important, right? And a lot of your settings for ray tracing are here. So this is, one of the more recent breakthroughs in Unreal. Unreal has been around for a couple of decades now. Since the 90s, it's been around. And ray tracing has come in a couple of years ago. It is now, something you can use on consumer hardware if you've got one of those RTX cards. Really, really powerful. It's been, one of the holy grails of uh, real-time rendering that people have been trying to hit for a long time now. And thanks to, number of breakthroughs even on the AI ML side, uh, we are able to do ray tracing in real time rendering. This was typically an effect that was only limited to offline rendering in the past, right? Games did not really benefit from this earlier, but it is far more physically accurate than the standard process called rasterization that we're seeing happening right now. So the way our reflections and all are calculated in this scene, this is not ray traced reflections. There are actually some project settings you will have to change and enable for this to kick in. So if you want to enable ray tracing on your project, the first thing you need to do is make sure you have a graphics card that can support it. This is most likely going to be an RTX NVIDIA card, or some of the more recent GTX cards. Just before RTX came out, they added some backwards compatibility. But again, that is not very optimized for ray tracing. Uh, the RTX cards actually have specific hardware that allow it to, you know, do the calculations needed for ray tracing more efficiently. But there are, number of sample projects that have this enabled. So the MetaHuman project has ray tracing enabled. So if you want to see the settings that are there in that, this has it. MetaHuman has it. The Archviz interior also has ray tracing turned on, and that's why you get these very, very nice realistic reflections and shadows and things like that. So if you have an RTX card, and we typically do a full 3 hour session on ray tracing, it is very in depth. So if any of you have an interest in that, just let us know. We can set up that training session where we dive deep into, you know yeah, we dive deep into the rendering features here. But I'm guessing some of you may not even have these cards. And what I'll do instead is just point you towards some tutorials that will help you enable ray tracing, see the difference. But in terms of photorealism, for especially a semi indoor environment like this where you have a lot of metal, you will benefit incredibly from ray tracing effects for things like reflection. It's also got, features for global illumination, ambient occlusion. I think the ambient occlusion ray tracing is very good. I'm not a big fan of the ray trace GI in the engine, but there's obviously Lumen that's coming out in Unreal 5. It's their new dynamic GI system. Really, really good. You'll probably be using that a lot more. But I'm a big fan of the ray traced ambient occlusion and ray traced reflections that exist in the engine. Translucency is decent, but it's a very, very tricky area. We'll talk about some of the weak points of a deferred rendering pipeline that Unreal uses. Uh, but unfortunately, translucency is one of those. So this is where, a lot of those settings actually live. Now, these are very, very important effects. Things like ambient occlusion and global illumination, they will actually break or make, how real your scene could look. So you can see the effect of, turning up ambient occlusion all the way and then down all the way. So without any occlusion, things look very unnatural. They look very flat. you overdo it, and you could be killing a lot of detail as well. So it's always about finding the right balance. And I told you I'll share this course with you. It's about it's actually a deep dive into how uh, this sample project was created by Epic. So let me see if I can find it. I think it's, yeah, this one, Rebirth. So it's an insight into how this was created, right? And how they, and this was pre ray tracing, mind you. So this was even before the engine had, you know the ability to do ray tracing. So I'm sharing the link with you. You can check it out. Um, but they actually talk about, how they approached creating an environment like this. What were some of the post process settings they used? What were, some of the configurations they used at the project level? How they brought in assets from Quixel? So I'm just going to let this play for a bit. And so they talk a lot about the fog effect as well, which is, the exponential height fog that they've used to get this look. uh, Talk about all the post processing settings they talk about. So you'll actually see a very practical application of, some of the things we're discussing right now in theory. Because depending on the look you're trying to go for, you will approach post processing very, very differently. So this is the course. I'll drop the link in the chat, and Sachin, just share these links with them after the session. But this is the one, creating photoreal cinematics with Pixel. I'm going to drop a link. Highly recommend this one. It's pretty short. You'll get through it in an hour, but it gives you a really good insight into how to set up something that looks photoreal. So dropping the link in the chat so you have it. Yeah, I think you'll really enjoy it. Especially if you go through it, sometime over the next couple of days, because a lot of what we've talked about, in post processing will be fresh in your minds. It will give you a good opportunity to. All right, so there's ambient occlusion, ray tracing. We're kind of staying away from today because, it's like I said, it's a much more in-depth topic. But there aren't too many settings for it. Like, it's just most of the settings just live here, and there are a number of CVARs that I should talk about. Um, and I just want to introduce you to the concept of CVARs later, so because a lot of the settings don't actually exist in the UI. There are so many knobs that you can tweak, and they exist in the form of CVARs that you can enter using console commands, or put into these project settings files, your ini files. And there are many different ways to enable that. So that's AO. Let's reset it to the default value, which is zero point 0.5. Set this back. So post-processed materials. So we've talked about materials before, right? And I think that the definition that we all know, or is that a material is a type of asset that helps you define the look of something. Now, all these assets have materials applied on them. Every 3D model here has some material applied on it. You can see over here, it's a material, it's got all these different textures. These are surface materials, right? We've seen them quite a bit in the past. We've constantly seen them, but there are special materials that can be used for post processing. And these are exactly the ones I showed you at the start, right? So if we go here to our post process, and you can create your own ones, but I'm going to use some ready ones over here just to show you. And it's created in the same material editor. They're really, really useful if you want to stylize something, specifically if you want to like have a toon shader or a 2D look, or some kind of very custom look. It's a great place to start. So I've downloaded this advanced cell shader pack. I believe it's free. It's on the marketplace. This is where the asset is for me. Advanced. I believe this was free at some point. Let's see if you can find it. Free forever. Yeah. So you can download this and use this right away. It's permanently free. Uh, you can. It's a pretty short download, and you can basically, once you have the material over here, all you want to do is you can add an array of different materials. So you hit the plus button over here and select an asset reference, and you can just drag and drop any of these materials. And immediately you can see the scene start to look different. Now the shader graphs for these effects can be fairly complex. You need to really know what you're doing. But there are some very simple materials also that you can use. Like if you're trying to do water, you can just add a nice blue tint, add some caustics textures, pan them, scale them, and you can get like a nice underwater look using post-processed materials. So again, massive difference, right, with just a post-processed material being applied. You can see how different my scene looks now. And you can open these up to see what it looks like, right? So this is the instance. You can add a lot of parameters that you can tweak, but the parent material is, and these are all different instances. So this is what I mean. Again, this is a really complex material, but if you break it down, you can understand it. Way out of the scope for today's session, but I'll just show you how you can set a material to be in the post-process domain, and the default is a surface domain that we've seen. So right now what we have over here on this 3D model is a surface material, but let's quickly just create, I just want to show you the one setting you need to have for a post-process material. So, and again, think of this like a filter. It acts on top of, you know, Unreal's rendering base pass. So you can right click here, select material, and I'm just going to call this test. So you open it up and your material domain, right? By default, it's surface. You want to change this to post process. Now, when you do that, you will only be left with the emissive node, and you can later kind of tweak the opacity so it acts like an overlay, right? So that you can change if you want. But for now, just quickly, like if over here, if I put a color, right now, because it's emissive, like the whole viewport is just going to turn black, entirely black. And that's typically not what you'd want. You'd want to kind of, you know, blend it to some extent. But yeah, if you put a texture here or something like that, you'll see the texture show up. So let me show you what I mean. And this is a little like the dirt map we were talking about. So right now I have this image here, and the moment you actually put this, right, you'll just see the whole viewport will be, it'll just be overridden by this. You can search for materials, add one, choose an asset reference. But yeah, if you have your alphas and all of that set up correctly, then you can use it like a stencil or something of that sort. Um, but yeah, it can leverage, and most things you can do in the material editor, you can do here. So like if I put a panner here, you'll see the texture will start to pan. So if you have like a nice caustics texture, you can simulate an underwater effect. So that's this one. And You can see that taking place. And these can be blendable, right? So you can blend, if you have a blendable setting on, you can kind of blend it with, what you already have. But a really, so one of the key nodes, right, that you want to see over here basically is, there's a scene texture node, and this is probably something that was not covered earlier. So with the scene texture node, you can get access to any of the individual buffers that we were talking about, right? Metallic, base color, whatever you have. And if you take this one called post process input 0, it's basically your default viewport rendered cell. So now if I multiply this is where it gets interesting. Um, Need a float 4 for that. So look at what's happening here. It's like I have a little portal now built in, right? And this is acting like my portal. And again, now I'm actually leveraging the alpha channel here. But so lots of possibilities, right? So if I want to do like let me see if there are actually some caustics effects here that I can find. So this is just one of the engine default textures that exist. And so I'm just panning it so it moves. Panning allows it to move, it takes the texture and it moves it in the X and Y based on the speed you give it. And you can also scale it with the texture coordinates node. This will actually change the scale of the texture with this node. And now I'm just multiplying these. And I'll change the speed here. I'm just going to flip this with a 1 minus. So 1 minus will. And you'll notice something pretty interesting starting to happen here in the viewport. You can start to see these little wisps that are coming from that texture. Yeah, so if you see the Spider-Man Into the Spider-Verse, there's a lot of post-processing happening there in that movie, and someone on our team had created, a very similar effect in Unreal. If any of you want to check it out, I'll send it your way. But you can actually take a look at, how the material was set up. But long story short, you can do all sorts of modifications and manipulations here in the material itself to give you a very custom look. And the most recent Dragon Ball Z game in Unreal was, you know again, these are like 3D assets, but it has a complete 2D look, right? Like the original anime. So you can, yeah, with post processing, you'll find a lot of applications. If you want a toon shaded look like an anime look or something like that, post processing is a great way to bring that to life. So anyway, that's how you create a very simple post process material. You can do all sorts of things like add your color tints in there directly as well. So like over here, if I want everything to have a bluish look to it, you can do all of that straight in here. And the moment you hit apply, all of it will act immediately. Or it wants a float for sure. Okay. And there we go. Right. So you have, and you can keep kind of tweaking the look till you get exactly what you want. So that's post process materials. So I think that's a good place to stop with, the post process volume. Again, some of these settings exist in project settings directly, and we'll talk about CVARs a little bit. Very powerful way to control things that are happening. Now, CVARs are not only to control post processing; they control a number of different things in the engine. Everything from rendering to physics to animation. You can tweak the way things behave with CVARs. But yeah, over here specifically under post processing, right? You will find in rendering, right? So you can again tweak a lot of this over here in rendering, like things like exposure. We saw that the knobs existed in the post process volume, but they exist here as well. Typically, whatever you have here in many cases can be overridden somewhere else in the engine. So just be careful. But you could always do something like disable auto exposure from here as well, uh, across the project, and then make sure your post process volume also has it set to what you want. So all the changes you make here, right, it actually tells you where this file is saved. It says that these settings are saved in the default game.ini. So if we go to rendering settings also, it will tell you default engine.ini. And I'll talk about like some of the changes you can make here that will actually affect that file, and we'll see this in action. So just keep an eye on this reflection capture resolution 128. Now there are these reflection probes. They calculate, they take like a spherical image or a cube map of your scene, and it will use that to calculate the reflections, and that happens at a certain resolution. Now if this resolution is higher, your reflections are going to look better if you're using baked lighting. This is just like one sample setting I'm talking about. You can change many different settings, but basically all of these settings they live. So if we go here to show an explorer, it will take us back to our project's content folder. But our project actually has a config folder, and this is where a lot of the settings are saved. So it clearly stated that this setting is saved in default engine.ini, and you can see all of these settings here, right? And these are actually variable values, so you can change like gravity, right, which is your standard 9.8. But if you want gravity to be like, let's say you're building something on an alien planet where gravity is lower, you can actually reduce this value over here, and this CVAR is actually controlling gravity. So there are a lot of rendering CVARs over here, as you can see. Like I changed auto exposure, and you can see it's set it to false. So any deviation from the the default, what Unreal gives you, any change you make, it'll show up here. So let's try that right now. Like there is nothing for reflections right now, as you can see, because it's just the default value. So I'm going to close this. change the value here to something that's higher, let's say 512. It's going to rebuild those reflection captures. So again, for like a games pipeline, a lower value is good, but if you're trying to do a cinematic and you are using reflection captures, you may want to crank up some of these settings and let it build all of this. But we'll notice in our file now, right? So if we go back to our file, going back into config, default engine, and you can see that there is a change now in the reflection capture resolution. It's 1024. It's what I set it at. So you can override it here, and I'm going to talk about some other places you can start to change these values. So let's talk about some really important ones, right? That will be important. So right next to above your tab button, in most cases, to the left of one, you have your backstroke key or your tilde key, as they call it. Uh, you hit that, and you'll see something here pop up. This is your console command, right? And you can put in a number of different instructions over here, set CVARs differently while you're testing things in the engine. So most of your rendering settings will start with R dot, right? And it gives you a whole list, and you can actually start to change some of these settings, and you'll just see there are over 1,000 of these values that exist, over 1,000 CVARs. So just know that beyond what you see in the UI, there are a lot of other things that can be changed, which is not surprising. There's so much going on in the engine, but this is just one of the places you can change it. So a lot of the things, like we were talking about bloom, so you'll see different settings for bloom. um, and there is some documentation on what the ranges for these values are, but just know that there can be massive differences made in the quality of the render, and a lot of this is not sometimes possible to run in the viewport. Like we talked a little bit about convolution bloom, and then the standard bloom method that exists. Now it says the convolution is good. So actually at the time of your render, right, like if you are creating a cinematic, at the time of your render you can force a lot of these settings to be higher. Like one of the most important ones I like to change is something called LODs. You may be familiar with this. LOD is level of detail, right? It's for your mesh. So your mesh will have different versions that exist at varying resolutions. So when you're further away from it, or when it's occupying less space on the screen, it's going to switch to a lower resolution version to be more optimized. But let's say we're creating a cinematic and you want Unreal, like you're not really concerned about what you see in the viewport. You're talking about rendering just, a really refined final frame that could take minutes to render. You're not stuck to that, 16.6 milliseconds or whatever target you're trying to hit for the game, or the interactive experience you're creating. You actually have the liberty to spend more time rendering a frame. You can actually bump up the resolution of all the meshes by using a console command to force all the LODs to be at the highest resolution. So you'll find console commands for everything. Like the one I'm talking about is r dot force lord 0. And again, nobody knows all the console commands. Nobody sits and memorizes them. A lot of it is kind of searching, first of all trying to see what you want to control, right? Almost every setting will have some CVAR that's tied to it in post processing. um, and even for something like, so once I set this to 0, it's going to force all the meshes to be at the highest resolution state. Now, this may not be optimum for the viewport, and you'll find a lot of other, like r dot. So quality, if you just type quality, like for your tone mapper, you can actually change this as well. And this will have like different, like one, two, three, each one is expecting. And this will keep changing, the way your scene looks. So again, when it comes to CVARs, what we can do is we'll send you some of the standard rendering settings we use when we're rendering out a cinematic. But that's where, so one place you can change these values is the ini file or the project settings, or you can start using the console command to enter it. But the console command is largely when you're trying to test it in the viewport. You close the project, it may or may not, hold. In most cases it will just vanish. And then what you really want to do is when you're using sequencer and you're rendering out the video, so sequencer has its own little rendering tool as well, uh, and an interface, but we now typically use something called movie render queue that is really meant to render out high quality, high resolution imagery. So you've probably already gone through this during the sequencer session, but I'm just going to show you real quick, um, and talk about the depth of field effect. I'll put in one camera because I mentioned that earlier. So I'm just going to call the sequencer test. And you can actually create a camera directly from here in sequencer. It's a type of camera that we call a spawnable. And let's just where's our character? Let's bring him in. So yeah, I'm just going here in sequencer, and we'll talk about the rendering settings at the time of your render export. So I'm going to create my camera here. And we were talking about depth of field, right? And I was saying I really like, the natural depth of field effect that's there in the cinematic camera. I don't really like to use post processing for that. And you can see this here, right? As I change my focus settings. So I'm focusing pretty far away right now. I'm focusing, couple of meters away. I want to reduce this value, and you can actually check this box over here, draw debug focus plane, and bring your focus much closer to the character here. So you can see this plane is intersecting, the area I want to focus on. So it would cut through the scene, and now we're kind of focused on the character. You can always use this eyedropper tool and just select exactly what you want to focus on. And yeah, something like this is good. And I can disable this. And now you can see my background is looking a little out of focus, which is nice. That's, something I want happening. It adds, nice cinematic touch to this. And I can exaggerate this effect by further tweaking the aperture, which is the opening of the camera. So at a value of 1.2, you can see the tree is looking very, very blurred out at the back. And now the effect is reduced. And if I open this a lot, everything is in focus. So if you want to use depth of field, I'd suggest doing it directly through the camera, not through post process. Yeah, so something like this. And anyway, I'm just going to quickly add a little animation here for the camera and turn on auto key. Yes, I've just got like a slight. Quick tip for cameras, right? When you're creating things that look cinematic, what I had here, like over here, it kind of stops dead over here, right? And what you'll find is when you have a real camera cut, right, it doesn't abruptly stop, right? You always want smooth motion. So I always like my my keys to be a little outside the sequence. So even towards the end of the shot, my shot will actually end here where the red marker is, and it will continue the motion. It will not abruptly decelerate and stop at the end. So it's just a smooth motion throughout the shot. Anyway, and one way to render this out is to click here, and this is, the old way to render, where you have a lot fewer, settings to control. Right, you can have control of high level things like, resolution and format and stuff like that. And then over here for cinematic engine scalability, you actually would want this to be on, right? And this will bump up the quality of your shadows and a lot of different things like that. And then the cinematic mode, again, that is not really a rendering setting, it's more about just hiding certain things. And then, you obviously can put in your console variables, and your console commands through Blueprint as well. So we've not really talked about Blueprints, I don't want to go there, but just know that you can do that. And that's what we would do earlier. But now Unreal has a tool, so I can just hit capture movie here, and this will be like done extremely fast and quickly at, my said resolution. But the tool we all really use now for this kind of workflow to render out good looking images is through Movie Render Queue. That's our guy dancing away happily. So this is what we have. But if you go here to Window and Cinematics, by default you may not even see Movie Render Queue. This is actually, again, because it's not used so much for games workflows, it's used more to render out cinematics, right? You can actually go into Edit, Plugins, and if you go to All, there is Movie Render Queue, and it's a beta. Sure, we'll use it anyway, and we'll restart. And now you'll see the option to render through Movie Render Queue. Now, Movie Render Queue is extremely powerful. It has, a lot of different settings, a lot, and you can set presets easily. Like if you're rendering out a lot of images from Unreal, it's, you know definitely the better tool to use, and much deeper control as well. So now when we go to Window and Cinematics, you'll see Movie Render Queue here. You can hit plus render, select whatever sequence, and you can set a batch. Like you can set a number of sequences. So you can, if you've got 20, 30 sequences, you can do that. And there is a settings file over here. So you can set this config file and reuse it across different projects. So what we'll do to make it a little helpful for you is we will actually share some of the settings we use for our renders. Again, this works on our machines with our config, but at least it'll give you a sense of what we're using. So over here, you can actually go here and create your own preset. So, let me start adding here. So you can choose what you want your output to be. We typically go with EXRs, they're 16-bit, they can store a lot more data. And then we convert these EXRs into video files. But you look at high resolution, you definitely want this, right? So with high resolution, we'll like, again, over here, if you've got a character or something like that, you can use, certain methods that offline rendering workflows use. So although you've created the scene in a real-time workflow, like now if you want to really maximize your quality, you can do some of this, like, you know uh it's like, again, don't want to get too deep into this, but turning on, the default, overriding the default subsurface scattering will make your skin, any character skin, look a lot more lifelike, and you can bump up the sample counts. But game overrides is a very, very important one. You want this. So I was talking about, that LOD0 command I had used. So over here, this is forcing it by default. So you don't need to go in and put all those console commands manually. So a lot of, the settings you want for something to look cinematic, this is just an easy way. You just put this in, and most of it is already just there by default. So it will take care of that basically. Just simply putting this in your settings will save you a lot of time and energy. It's basically changing CVARs. And then if you want to have burn-ins and stuff like that, you can. Now console variables, right? CVARs again over here. Uh, you can add a lot of your custom ones. So the ones that were showing up here in the command, these ones over here, you can actually add them directly into your setting for, so you don't need it working persistently in your viewport and slowing down your viewport, but at the time your image is rendered it will really you know keep it at the highest, like whatever setting you want, you can force it to be there and not slow down things in your viewport. It will, the render itself will take longer to happen, and in some cases it may even go to like a couple of minutes. I'll show you some of those settings for multi-sampling. Wrong one. So yeah, if you go, yeah, you'll actually see. So for these are if you want to render out specific passes. We don't want to do that right now, but you could do specific passes from the gbuffer, like the metallic pass or the roughness pass, if you want something very specific like that. If you go to anti-aliasing over here, now this is where you can really make it act more like an offline rendering pipeline, where you can sample over multiple frames. So for effects like anti-aliasing, especially when there's a lot of motion, right, you can really change this and basically bump up your sample counts massively. And we typically go with a value of 64 here. That means it will render 64 frames for each single frame that needs to be rendered, and then it will do its, so obviously it takes that much longer, right? If you 16 is also a good setting. Anyway, so we mainly talk about temporal sample count, and we bump that up so it samples over multiple frames to give you something that looks a lot more accurate. Now that's not something you can do real time in the viewport, but you can force it over here. So again, I'll share some of our settings with you, so you get you know nice looking imagery. But yeah, you can force it to do multiple samples. So game overrides you want almost always. High resolution is useful. Sometimes if your GPU is not powerful enough to handle, if you go to high resolution, you can turn on tiling, and tiling will allow the GPU to calculate things in different sections, and it will stitch those together. There are some caveats to that, but it's if you're using an underpowered system and you want to do like a 4K render, you can bump up the tile count to do that. Then burn-in, probably not something you really need to use. This is like really important in the film pipeline, so you can ignore that for now. Camera, this is just kind of shutter timing. And let's not get into color output, but Unreal does leverage something called OCIO, where you can have different config files. This is really useful if you're jumping between Unreal and different packages, like Nuke for compositing. You want there to be, predictability in the color output. So those are the settings that exist. And then finally, what type of output you want, right? So like I said, we typically go with EXRs and stitch them together, but PNG is also good. It's pretty fast, and I can just for now, I'm going to turn off some of this. Just leave game overrides in there. And output, again, your final resolution, all of that, you can set. And I'm just going to hit accept, render local. So render remote is interesting because you can have, so basically what this also does is it has the ability to do clustered rendering and leverage multiple systems. So you can see a preview of a render that happened. And all of these are by default, you can see where it's saved in output, so you can set the directory you want it to be saved in, and you can see ours is going to be saved uh and you can set absolutely wherever you want it to be. It doesn't have to be within your project, it's up to you. So the default one is obviously it goes into your saved folder. Just go there. And you go to movie renders, you'll see all the individual PNGs are rendered. These are just images, you can stitch them together to make them a video. So sure, you can, any custom file names you need. And then one of the things I'd recommend doing, right, sometimes is giving it a little bit of, a warm up, right? So you'll see some settings for warm up. You'll even see that in sequencer. So if there's any physics or particle systems or anything that needs to kick in, it just gives it a while to start simulating before the render fires. So that's something I would recommend using. And yeah, you can put in all your console commands here. So once like whatever it may be, that r dot force lord, and then the value that goes with it would come here, right? So those types of things can be done over here. Yeah, I guess that's all we have for today. So thank you for sitting through the session. I'd like to give you some time back to just think about, the assignment, how you want to execute it, maybe spend some time, brainstorming, thinking about resources that you want to use in your projects, and just coming up with a little bit of a game plan. And like I said, we'll be here to support you. If you need help with anything, our TAs and instructors can, respond over email, or we can spend some time during these sessions talking about issues you're running into. Uh, yeah, I'll send you the link for the assignment. Um, I'll actually send the PDF over as well. So, Sachin, I'll just share that with you. Yeah. And then you can just send them the PDF when you. Cool. Thank you, everyone. Hope you enjoyed today's session. I know it's a little different format wise from what we've been doing earlier, but there's a lot we had to get through. And really, it's easy to get into the weeds here. So, I wanted to give you more of an overview, and then, give you your own time and space to navigate post processing and rendering. All right. Any questions? Great. Okay. Well, thank you, everyone. Have a great weekend. Yes. Have a great weekend, everyone. See you.
Thank you, guys. Bye.
Have a great weekend.
Thank you.
See you. Bye.